right, in this video we're going to be talking about the logarithmic function in section 4.3. On this video we're down to the properties of the logs. So we have a list of properties that we're going to be using, and this is going to help us as we finish up this chapter. Towards the end we'll be solving equations, and this is the pivotal information that we need to be able to solve those equations. Now, you're going to notice that these log properties are going to look very familiar. They should look familiar because they're very familiar to the exponent rules. You might remember the product rule with exponents. If you had like bases, like x to the fourth times x to the second, like bases, and you were multiplying, so the product rule is multiply, you would add the exponents and get x to the sixth. So, with our logarithms, it's going to be very similar look, only some things have kind of rearranged here. And if you see on your notes here, the way it's listed is if you have a log of any base, so it says base B, because it doesn't matter if we're doing log base 10, log base E, or any base log. So any base log of two things that are multiplied together, so we'll say an m times n, that it equals the log of m plus, because it's multiply, plus the log of n. So you add. When you multiply, we add the product rule. For example, I am old enough to remember this just very vivid, very light memory. I want to say vivid memory. Very light memory of being in 7th or 8th grade, and we had logarithm tables in the back of our book. I'm sure that's very ancient sounding. But so logarithm table only went to 100. We would have log base 10 of 1 equals a decimal approximation. Well, if it only went to 100, what are you going to do if you're doing log of 200? Well, we were able to derive log 200 by breaking it apart and saying that's the same thing as saying log of 2 times 100. So 200, same thing as 2 times 100. And then using this rule that we have here, and assuming it's just a base 10 log, that would be the log of 2 plus the log of 100. I would know, and I don't think I understood this at that point, but I just barely remember having these log tables in the back of the book and my teacher just drawing our attention to it and saying, look at this. But I didn't understand what it was about. But this is it. Now, and it's come back to me as I taught this. I was like, man, I've seen that before. Why would anybody need to do this? Because you might be thinking this, because I was too. Well, you can just do it on your calculator, and we can't. We could just type in log 200, boom, equals on our calculator. And let's just do so to see that that the rule works. I mean, I know you believe me, but it helps our brain to kind of accept it, or it helps me when I do it also myself. So log of 200, if we hit that on our graphing calculator, and let's all do, we're doing a base 10, just a regular common log. Log of 200 is 2.3010-ish. But it is the same thing, if we directly do it on our calculator, as breaking it apart into 2 times 100. Looking up log of 2, again, we can do this on our calculator. Log of 2 is the 0.0 or 0. Oh, shoot. Try that again. Log of 2 is 0.3010-ish, that part of it. And then log of 100 is 2, and then the rule says, because it's multiplied, 2 times 100, we should add it and see it would be exactly the same thing. Now, again, you can just do those on your calculator. If you have a number like log of 200, you'll simply type that on your calculator and just get the answer, 2.3010. But what if, and this is what we'll do in your homework, we said, what's the log of xy? Expand that, write that, expand it. That one we just need to know the rule says, if it's written as times, we write it as add. So that's what we'll be looking at in your homework to test this, your understanding of the log properties. We'll use algebra. So if it says log base 7, let's do a different base of, let's say, z times a, for example. You would write log base 7. These were understood to be tens, so we didn't have to write anything. But if there is a base, we have to drag it along. Log base 7 of z, and then because we have a times there, we say plus log base 7 of a. And that would be our expansion showing the understanding of that rule. So that's the product rule. Okay, next rule. The next rule is the power rule. The power rule says if you have a power to a power, it multiplies. I'm going to remind you of what that looked like with exponents. If you had x to the third raised to the fourth, the exponent rule says you multiply exponents to exponents. Okay, that's what it looked like for exponents. With logs, it would look like this. Log base, and let's see how it's written officially on your note packet. Log base A of an m raised to a p. We could write that as, and a log is basically the answer to the log is an exponent. So this is an exponent raised to an exponent. So we would bring this in front of it as a multiplier. P times that. Write it as P times log base A of m. So again, the log is an exponent, so it's an exponent to an exponent. So you bring that outer exponent down. It could be down in front of it too, but it really looks better and it's easier understood if you bring it in front and say it's a multiplier onto that log. So they multiply. So for example, if I had log, let's do a base 10 of x raised to r, I could write that as r in front of that, r times log base x. If I have log a plus b raised to the z, again it's base 10, the z comes in front, it's z times whatever we got this log of. So exponents wrap around front as a multiplier. That's the power rule. Here's another example you might see in your homework. If you have log of xy squared, let's do it in parentheses. Or actually, let me leave it like this. So we would write that as log of x. Because of the times, we say plus log of y squared. And then we can go one step further. This exponent on this log then wraps in front of that. This one stays as is, log of x plus 2 in front of this log, log of y. All right, power rule. All right, next rule. Rule number 3 is the quotient rule. Quotient means divide. Sorry, mine got stuck there. Let me remind you about our old exponents. Like if you had x to the 10th over x to the 2nd, that would be x to the 8th. So whenever you had like bases, whenever we had exponents of like bases, we subtracted 10 minus 2, x to the 8th. Again, you had to have like bases. A lot of these rules rely on that like base idea. Well, so the same thing happens here with logs. The way it's written in your notes, log base anything, so any base this applies to, of an m divided by n, just any two things divided, can be expanded to log base a of the m minus log base a of the n. So you subtract the exponents. Basically the logs, answer the logs of the exponents, so these are exponents. And the way you might see that written in your homework, we'll start putting some of these together. You might see log base 10, let's do a base 10 of x over y. We could write that as log of x minus log of y. Let's put a few more things together. If you had log, let's say of base 3 of x squared y over z, lots of variables there. We could expand that, each part, sort of like diagramming in a sentence, I feel like. You've got to break it all down into its pieces. You've got to drag that log base 3 around. If it's got anything other than 10 or e, we have to show it. It's not understood. So log base 3 of the x squared. There's a times there, so we say plus log base 3 of the y. Then divide will be minus log base 3 of the z. Then if there's any other steps you can do, go further, and there is. If there is any exponents on the individual logs, those need to be wrapped around as multipliers. So we'd say 2 times log base 3 of x, and the other two are just as they were. Okay, starting to put some of these rules together. Those are the big three: product, power, and quotient, that we'll be using in the last couple of sections of this chapter to help us solve all the log equations. So again, those are the big three. There's some other rules that come up less often that's mentioned next. The next rule you see is just like a way you might see an expression listed and how that we can write an equivalence of that. So if we had log base A of a to the x, or a to log base A of x, basically what happens is these like bases cancel each other out and just brings down the x. It just equals the x. These kind of cancel each other out, just bringing down the x. Here's an example. Log base 10 of 10 to the 5th would be of this form. These two things are the same, so it just brings that number down. That would be 5. You can try that one on your calculator. Next, let's see. Here's another form you could see it in. Let's see. Oh, that's the same thing we just did there. Okay, the next one, the next new one, if we have log base A of an A like that, it equals 1. And we've seen this before, like log base E of E, or ln of E is probably a better way to say that. We've seen that. If you have ln of E, that is 1. Check that on your calculator. ln of E is 1. Log, another similar, would be log of 10. That would be an understood 10. If these are the same number, they kind of cancel each other out. It just equals 1. But it works for any base. Log base 7 of 7 would be 1. If these are the same numbers, it equals 1. Okay, next rule. Log of anything, base anything, of 1 has to equal 0. Any base to the 0 power always equals 1. We've been seeing some examples of that. Log base 6 of 1. You can check that. 6 to what power is 1? And that has to be 0. So any base, if you got a 1 there, it has to equal 0. And then I think lastly, rule number 7, we used this one in an earlier video, is the change of base theorem. The change of base theorem helps us with a ratio if we don't have a base 10 or E. Change of base theorem. So for example, and this is what it's listed in your official notes or in your book if you look it up, if you have log of any base, we can write that as the log, any base, whether we do base 10, base E on our calculator, of the m, and you got to use the same base of the n. So it basically says the log of this, wait a minute, I think I'm missing something there. That should be a B. There is no N, sorry about that. It should be B. The letters are kind of arbitrary, whatever letters they use to describe it. We're going through this, but these could be any letters. It's just saying it could be anything. But it's the log of that divided by the log of that. That's the change of base. You do the ratio of that over that. And you can do the log of any base is what it's trying to say to us. It can be the log base 10 or the ln of E. It can be the ln or the log base. So an example, when we did like say log base 3 of 7, that's not a neat one that comes out even. So the change of base rule is needed. So we do the log of 7 divided by the log of 3. So you can do the log of 7, but if you do, you use the log in the denominator as well. Or you can do ln of 7 divided by ln of 3. I want you to pause the video. I want you to type that in and see that that is so. All right, let's see what it should be. When I do log of 7 divided by log of 3, 1.77-ish. Do it with your ln button as well. ln of 7 divided by ln of 3. And lo and behold, same thing, 1.77. Same answer, different base. You could do it base 3 or base 7, but you don't have that handy on your calculator, but it's saying you could. But we won't. So pick one of these to do that. You do get the same answer. Notice that 3 to that power should equal 7. We can check our work and see that it's so.